everyone, welcome to the second lesson for topic 4.3 momentum. This is the last lesson under this topic as well. So for this lesson, we will be looking at a new principle which is known as the conservation of linear momentum, and we are going to use this principle to help us to solve the problems that can be modeled as the direct impact of two bodies. Okay, so in the first lesson, we learned about the definition of momentum, right? So all the questions that we solve are actually the questions that focus in one single object only, and we are just using the momentum formula and also some super formula to help us to solve the question. So under this lesson, we are going to look at two objects, and the two objects collide with each other. So we want to find out what is the direct impact occurs at that time and what is the impact on their velocity after that and so on. Okay, and you'll be learning some new terms as well, as you can see the Coalescence here. Okay, so we are going to look at it in a further when we discuss about the term. Okay, so let's try to move on to the notes part. Alright, so in the previous lesson, we learned that momentum can be defined as mass in motion. So every moving object has a certain momentum. Okay, so this momentum is given by the symbol P, and the formula is the mass multiplied the velocity. Okay, so which means the momentum is directly proportional to the mass and the velocity of the object. So the unit of momentum is Newton second. Okay, and we also learned that momentum is a vector quantity. It will be always following the direction of the velocity. So that's why denoting a positive direction when we try to solve the questions is very important when we solve momentum question. Okay, so for today's lesson, let's try to look at the part for conservation of momentum. So the situation that we are going to look at is that there will be two objects involved and they are interacting with each other. So in simple words, which mean that in all the cases that will be encountered, right, the two objects will be colliding with each other. So we are going to understand this principle or this whole idea by using this simple situation. So there are these two particles A and B moving towards each other. Okay, so maybe A with a certain initial velocity like UA, then the same thing for B, the initial velocity UB. Okay, so let's try to imagine when they collide with each other. So at the point of colliding, so imagine that if you are clapping your hand, right? So when your left hand and your right hand get in contact, then you know that there's actually a certain force that actually transfer from your left hand to right hand and right hand to left hand, right? So the same thing when these two objects collide with each other, then definitely there will be an force that actually transfer from A to B. So this is the A is the force that exert from A to B. Then similarly, because they are colliding with each other, then of course B is going to exert a certain force on A as well. Okay, but it's just that we don't, when I try to use a different color here, which means that we say that the magnitude might be different. Because for example, if let's say A is moving in a faster rate, then B is moving in a slower rate, then you can imagine that the momentum is different. Then after that, during the impact, the transfer of the momentum wouldn't be the same as well. Okay, but then according to Newton's third law of motion, we know that for every force there will be an equal and opposite force. Am I right? So that's why these two objects is going to exert an equal and opposite force on each other as well. Okay, so which means let us try to look at them separately. So for the first diagram, we are going to focus in the object A. So for the particle A, right, we know that it's the green color one. Okay, B, particle B is exerting a certain force on A. Okay, and because of Newton's third law of motion, so A is going to react with an equal and opposite force. Am I right? So that's like the green color one. So now same thing, when we try to look at particle B, so there's a force that actually exert from A to B from the collision. Then after that, there will be an equal and opposite force that actually acts on A as well from Newton's third law of motion. Okay, so now let's try to regroup the regroup these forces that we have on each particle. So you can see, right, what is the force that actually exert on this particle B? It will be the force from A to B, which is the green color one. Okay, then after that, there will be a force that actually from A to B as well is the red color one, right? So the same thing when we try to look at the particle A, then we have these green color forces that is moving towards A. Then we have this red color force that is moving towards A as well. So as what you can see here, what is the force that actually, what is the net force at the end? You'll realize that the green color and the red color should be, the green color and red color is different value, but as you can see, the total net force here is actually the same with the total net force here. Am I right? So although they have the different value, but because of Newton's third law of motion, the equal and opposite, like the resultant force, that will actually cause that the contact force between the objects in the impact is going to be equal and opposite as well. So that's why in another words, it's going to be the same thing for momentum. So the momentum transfer from A to B is going to be equal and opposite to the momentum transfer from B to A. Hence, at the end, what you can realize here is the momentum that lost in A is going to gain by the B. The momentum that lost by the particle B is going to gain by A. So that's why at the end, right, there will be no change in the total momentum. So this whole idea is called as the principle, is the thing that we mentioned in the learning outcome just now. So this is called as the principle of conservation of linear momentum. Okay, conservation of linear momentum. So in a simple words, what is this principle is trying to tell us is that the total momentum wouldn't be changed. Okay, so as long as there's no there's no external force that acts on this situation lah. So which means in a system, so for example, when we talk about a simple thing in, especially if you are learning physics, right? So we know that if let's say there's like the system like tied the two pendulum together, and if let's say this is kept in a box that's like a vacuum one, so that's why there's no air resistance and so on, right? So you realize that this pendulum, or you actually see this in movie and so on, so you know that this pendulum will actually kept on colliding with each other until forever, right? This principle states that the total momentum before the impact, so I'm just going to write P here. So the total P before the impact is going to be exactly the same with the total P after the impact. Okay, so as I mentioned just now, because of they are starting with a different velocity, so do not assume that like velocity of A will become velocity of B, then velocity of B will become velocity of A. That's not true to say that, but it's just that when you calculate the momentum, the total will be the same. So which means when we try to look at this situation, so these two object is going to collide with each other, then the impact actually brings them towards the other different direction later. So we know that the V actually includes the part for the direction already, right? So which means that the mass for A multiply the initial velocity of A plus mb, mass for particle B, and the initial velocity of B. So this is like the total momentum before. Okay, so the P, the total, let me try to write the full thing. So total P before. Okay, and then the second part is going to be equal to the final velocity, right? So mass A, final velocity A, mass B, final velocity B. So this should be the same with the total momentum before. Okay, so that's basically the idea of this principle. So let's look at example 1. All right, number one, the particle of mass 2 kg travels at a speed of 5 meter per second. Okay, and then it collides with a stationary particle of a mass of 8 kg, which is stationary, right? So it doesn't put any arrow here, so to indicate that it doesn't move. So after the impact, the 2 kg mass has a speed of 3 meter per second, and the direction of motion is reverse. Okay, so which means after the impact, then the final velocity for this particle become negative 3. Am I right? So towards the other direction. So something that we can always try to use is either you want to draw it like before and after. So which means that this is like before, then after, then you can try to draw the other one, which is like moving towards this direction and so on. So the other alternative that you can always try to do is that you remember that the top is your details before the impact. Then the details at the bottom here is going to be the information about after impact. Okay, so this is something that you can try to do. Or if let's say you try to use the other color, that doesn't matter as well. Okay, so let me try to do before after. Maybe I think that's clearer. Okay, so this is after. Then you know that this object is going to move to a different direction as well, and the speed is actually 3. Okay, so find the speed of the 8 kg mass after the impact. So it's here, right? Okay, so let's try to imagine, right? My questions is, where do you think this particle would move, yeah? By using your logical or like general knowledge. So if let's say this particle hit this particle which is at rest, and this particle actually rebounds back. So what do you think is this direction? Do you think that this particle will actually move in this direction? Yeah, I mean that's quite illogical, right? You mean like they move towards this direction and it collide with this one, then after that suddenly both of these objects actually move towards that direction. Then you know that I mean the common sense that is actually wrong. So that's why you can actually guess that this particle is actually going to move towards this direction. Okay, but that actually doesn't matter because in our formula we know that the v stand for velocity. So by having a positive answer or negative answer can actually tell you the direction. But having this common sense is very important when you try to solve the question to understand that whether the answer that you get is something that's logical or not. Okay, so that's the idea of it. So let's try to solve that. So the total P before is going to be equal to the total P after. Okay, so for the initial total momentum is going to be the mass 2 kg multiply the speed, which is 5. The same thing we try to denote, maybe going that side is positive. Okay, so 2 5, and then this is stationary, right? So that's why it's going to be 8 times 0. Then equal to, how about the after? So you see this direction is in the opposite direction than the positive direction that we try to denote. So that's why it's going to be 2 kg and then negative 3. Okay, and then plus 8, and the v is what we want to find. So now let's try to solve this, and we are going to get 8v, and that's equal to 10 plus 6. Okay, so you'll realize that v is equal to 2 meter per second. Okay, so you don't need to change anymore because the question asks for speed, right? So since it's a positive answer, then you do not need to change it. So that's why you see, if let's say the v here is having a positive value, then which means it's in the direction of our positive direction, right? So which means our guess just now is actually correct that this particle is going to move in this direction, which is a logical one. Okay, so that's the idea of it. So now let's move to number 2. Two ball bearings are moving directly towards each other, so it's the same thing, so which means that the first ball is moving towards this direction. Okay, then after that the second ball is moving towards each other. Okay, so first ball bearing has a mass of 20 gram and is moving at 3 meter per second. So the second ball bearing has a mass of 25 and is moving like 1 meter per second. Okay, so later make sure that one of it should be a negative value. So after the collision, the first ball bearing is stationary. So which means after they collide with each other, so this ball bearing actually stays. Okay, then after that, the question want to ask what is the speed of the second ball after the collision. Okay, So now the same thing, you can try to have a guess. What do you think is the direction of this second ball? So when they meet each other in the middle, and this second particle actually stop there. So what do you think is the direction of this second ball? So let me try to use the other color. This is like just a guess. Okay, so imagine by using a logical guess, right? You imagine if let's say this particle is moved towards this direction, then it's not logical that the second particle will actually stays there. Am I right? Because this particle is going to knock on this particle again, then they move together. So that's why this particle wouldn't be in stationary state already. So that's why if let's say the first particle is stationary, which means we can assume that the direction of this second particle should be towards the other direction. So that's why it's like they collide, then after that this stationary, then after that the other one move towards the opposite direction. Okay, so now let's try to prove whether our guess is correct or not. Like what I said, this is just a guess. It wouldn't be, that's not so important when we try to look at the question, because you can definitely differentiate it by looking at the sign of the velocity. It's just that it will be good if you can have this sense in your mind, so you know that the answer that you get, if let's say it's a positive one, then do you think that's correct? If you are getting a negative one, then do you think that's correct? Okay, so let's try to denote the direction that we try to guess as positive maybe. Okay, so what is the total momentum before? So which means it will be 0.02 multiply 3, okay, because this is in the positive direction, and then plus 0.025, okay, and it's negative 1, then it will be equal to this stationary already, right? 0.02 times 0, and then plus the other part is 0.025, and then we put as v. Okay, so now let's try to solve it, and we'll be able to get 0.025 v will be equal to 0.06 minus of 0.025. So that will actually give us 0.035. Yeah, okay, so 35 divided by 25, and we are able to get 7 over 5, and that is 1.4 meter per second. Okay, so you can see it's a positive answer, so that's why it's in this positive direction and it's aligned to our guess. So if let's say you get a negative value here, then you might need to check everything and see whether you left out anything, because that's not going to be logic in this question. Okay, so number 3 now. Okay, a lorry of mass 3 tons is moving at a constant velocity of 4 meter per second. So let me try to use the purple color to indicate this lorry. So yeah, that's this lorry with 3 tons moving at a constant speed of 4 meter per second. So when it collides with another lorry of mass 5 tons moving at a speed of 2 meter per second in the same direction, okay, so which means that's another lorry. So my question is that where do you think I should draw the lorry? Is it at the back or is it at the front? So try to think of how the logic of this situation. So if let's say the lorry colliding with each other, right? Imagine when you're driving a car now, when we talk about like a car accident. So obviously it's the car at the back is actually driving with a faster rate. So that's why it collide with a car that's driving with a slower rate in front. Am I right? Because if let's say I were to draw this 5 tons of the 5-ton lorry here, right? Then what do you realize here is this actually move in the speed of 2, then this actually move in the speed of 4. Then this lorry is actually moving quite fast, right? So when it move faster, so which means the distance that it travel is faster. So the second lorry is not even can reach the purple lorry, you get what I mean? So that's why obviously when you try to draw your force diagram, then you know that the 5 tons lorry here should be the one that in front. So it is like slow enough so that this lorry is catching up the distance between this lorry and the collide. Okay, so 2 tons is here. So the speed of the 5 tons truck is increased to 5 meter per second by the collision. So which means the 5, this is before, so this is after. So we doesn't know what happened to the 3 tons lorry yet. Okay, so we know that this 5-ton lorry is actually increases to 5 meter per second. Okay, so let me ask you a question. So there's like different case lah. So normally when they are in the same direction, so you can imagine that so this is one way dimension, right? So obviously the thing that you can have is either they stay in stationary. Okay, so this is like stay, then after that it continue to move, or it's like that. Okay, so imagine if let's say this lorry collide at the from the back of this lorry. So do you think that's possible that this lorry after collision it become this way? It's quite impossible, right? When you try to think of the logic of it. And then this is actually, I mean, although this weight is actually larger, but maybe the impact can actually force this lorry to go to the other direction lah. But it wouldn't be logical if let's say these two lorry actually move towards the left hand side after the collision, right? So which means it's like going here, then after collision, then suddenly both moving towards that side. So that's like quite impossible. So that's why if let's say we say that the speed of the 5-ton truck actually increased to 5 meter per second and is increased here, if let's say it's going to the other side, maybe if you want to talk about it's possible, then maybe the speed is eventually is going to be smaller. So in this case, if let's say it increases to 5 meter per second, then the ideal situation will be it actually moving towards the same direction and now become 5. Okay, so which means that this speed is going to be actually slowed down because partial of the momentum is actually transferred to this lorry already. So the momentum of this lorry is going to be lower. So you can see from the question show that the speed of the 3-ton lorry is actually 1 meter per second. So that's why you obviously you can see that the magnitude of the velocity here is actually decreasing from 4 to 1. So but then we doesn't know what's the direction yet, so we need to find out what's the direction of motion. So that can be proved by the positive sign or negative sign of the velocity. So the same thing, total P before is going to be equal to the total P after. So the before one, we have the 3 tons multiply 4. So going that side is positive lah. Okay, moving to the right is positive direction. So 3000 times 4 plus 5000 times 2 equal to the total P after. So we have this one we doesn't know yet is what we want to find. So 3000 multiply the V. Okay, and then this moving towards the positive direction as well. So that's like 5000 times 5. Okay, so now let's try to solve this. So I can get 3000 V. Okay, so 22000 minus of 25,000. Okay, so from here that I can get 3000 V is equal to negative 3000. So from here I can get V is equal to negative 1. Okay, so this is velocity. So it indicates that the direction of this truck is in the opposite direction of the direction that we denote as positive. So that's why it actually moved towards this direction. Okay, so prove that the speed is 1 and then is moving in a reverse direction. Okay, so which means after they collide, so the first lorry continue to move to the front, then the second lorry is actually colliding and bounce to the back. So that's the idea. Okay, so we'll be looking at, so for these three first examples, so everything that you look at it is like they collide with each other, then after the impact they actually move to a different direction. Okay, so now we'll be looking at the idea, what if after they collide then they move together in the same direction and the same velocity. Okay, so that's a new term that we'll be looking at. So let's move on to the next section. Okay, let's look at the part on coalescence and also explosion. So sometimes instead of moving apart after an impact, the objects may coalesce as well. So yeah, let me try to write down the word. Okay, so this this term actually means that the two objects, they collide with each other, Then after that, they move off together. So the idea is together. So which means that these two objects is having a same final velocity at the end after the collision. Okay, so in this case, we can model it as they are actually merged into a single object. Okay, so which means that when we try to calculate our final, the total momentum after the collision, so the total mass is basically equal to the sum of the individual mass. Okay, so the opposite of coalescence is actually explosion, but we are not going to look at so much on this part under this syllabus. So basically, it's the opposite of the cases that we mentioned just now, is that the particle are actually merged together initially. Okay, then after that, what happened is they are split into two after that. Okay, so let me try to give you a simple example. So maybe there are these, so this is like the vehicle. I mean, this is not so practical in our real life, but that's the idea lah. So if let's say this is the vehicle, then after that, this is this person. Okay, so this person is trying to run, and then after that, what happened is it jump out. Oh, sorry, it jump onto the vehicle. Then now two of them is moving together. Okay, or the other case that's like more appropriate is not more appropriate. Like more practical one will be, for example, if that's like two people that is doing ice skating. Okay, then after that, so obviously by looking at the lorry example just now, so the first person here is in a slower rate than the second one is faster rate. Then what happened here is that the second person actually catch up. Then after that, they hold hands together and they move together. So this is actually an example of they coalesce together. Then after that, when they actually release their hand and they go back to the initial state, then which mean that the explosion happened lah. So I hope that you can get the idea of it. Okay, so we'll be looking at the two example that they moved, the objects moved together. Okay, example 4, a block of mass 200 gram moving at 4 meter per second makes a direct collision with a larger block of mass 500 gram moving at 1 meter per second. Okay, so on the impact, the two blocks actually coalesce. Okay, so which means that, before, so yeah, let's look at the part A first. So find the speed of the blocks after the collision when the blocks were initially moving towards one another. Okay, so which means that the two blocks is moving towards each other. Then after the impact, so these two blocks actually move together. So we're not sure whether towards this direction or that direction, and we are going to find it out. Okay, so part A. So let's try to denote going to right hand side as the positive maybe. So the total momentum before is 0.2 then times 4 and plus for particle the other larger block 0.5 and then negative 1. Okay, and it's equal to, so remember when we find the total momentum after, so since their velocity is going to be the same, right? So we can always try to combine the mass together. But if let's say you try to separate it, that doesn't matter as well. At the end, it's just factorization or not. Okay, so which means we have the mass 1, 0.2 plus the mass 2, 0.5 and multiply with the final velocity. Okay, so it's the same thing. If you split it out into 2, then it will be 0.2 v plus 0.5 v. The idea is you understand that or when they coalesce, right, which means that the v is going to be the same for these two objects. Okay, so 0.8 minus 0.5, so we can have 0.3 equal to 0.7 v. Okay, so v is equal to 3 over 7. Okay, and that gives us three significant figure is 0.429 meter per second. Okay, so that's basically the answer for part A. Okay, so now let's look at part B. Find the speed of the blocks after the collision if let's say the blocks were initially moving in the same direction, so which means it's like this. Okay, so as you can see as well, so this block is actually moving in a faster rate, so it collide with this. Okay, so that's the idea. And then let's try to solve this out. So positive direction, moving to right hand side also. So 0.24 plus 0.51 equal to 0.2, 0.5v. Okay, so 0.7v equal to 1.3, so 1.3. Okay, so v will be equal to 13 over 7, which when we try to change it to decimal is 1.86 meter per second. Okay, let's try to understand this question in a bit. So imagine what happened here is that for A, right, so you can imagine that this box is smaller one, but it's faster rate. Okay, so this box is a larger one, but it's slower rate. So when you try to look at the momentum itself, this is like 0.8, this is like 0.5. So that's why when they collide with each other, then obviously this is going to create more momentum. Am I right? Because this is like 0.8, this is 0.5. So that's why at the end you'll realize that the block actually moved towards this direction. It's because of the momentum of this smaller block is actually bigger. So that's why it actually caused this thing to actually move together towards the right hand side. Okay, then something that you'll realize here is that this velocity is actually lesser than the velocity initially, which is 4 and also 1. So that's correct, right? Because when we try to look at like this thing actually move a very fast rate, then after that the force is going to actually used by this block to actually change a direction because the mass of this is actually quite high as well. So some of the force is actually used to change the direction of this one, then they move together in the other direction. So that's why the velocity is like lesser. So this eventually is starting with 1, so it cannot be like more than 1 for the velocity. So the same thing when we try to look at B. So we have this block, the smaller one, faster rate, so it's 0.8. After that 0.5, so here 0.5, right? Okay, so you can imagine when they move together, you can imagine that the total momentum is like adding up each other. So that's why both of them, when they move together, right, it will be towards the same direction. But obviously the speed that you are trying to get is not as high as the one that for the single particle. You get what I mean? Because like two of them combined together already, then the mass become higher. So when the mass become higher, then which means the velocity will eventually like spread out. So which means that the first particle at the back here actually helping this particle to move faster. But because of some momentum, it's actually transferred. So that's why this trying to like move in a slower than two of them actually move together with a velocity of 1.86. So you can see this value is actually higher than 1 but lower than 4. Okay, so that's right, talking about the logic of the situation. So let's look at number 5. Okay, number 5, a girl is sitting on a sledge. So the girl and the sledge has a combined mass of 50 kg. When the girl and the sledge is moving at a velocity of 2 meter per second, the sister standing in front of the sledge, okay, I try to indicate the sister, standing in front of the sledge, throws a snowball at the sledge. So this is like the snowball. Okay, so you actually throw it. So obviously it trying to throw towards the sledge, right? It's not towards this direction. Okay, so the snowball has a mass of 0.2 kg and is traveling at a speed of 10.55. Okay, so the snowball, the girl, and the sledge actually continue together when they collide. So find the new speed of the sledge. Okay, so which mean for this part, yeah, I mean at the end, all these subjects actually move together. So that's why it's like a coalescence question as well. So let's try to solve that. So the total momentum before, let's try to denote this direction as positive because you can actually assume that although the velocity of the snowball is like very high, but the mass here is actually pretty much, the multiples, right, is actually much more higher when we compare to the multiples of the velocity. So the snowball wouldn't be able to change the direction of this girl. So yeah, before then we have the girl and the sledge multiply with the speed, okay, plus the snowball and negative direction, so negative 10.55. So equal to all the mass together, we have 50 and then plus 0.2 for the snowball and move towards together, so the same V. Okay, so just to solve it, then we have 50.2 V it will be equal to 100, then minus off 10.55 times 0.2, and we can get 2.11. Okay, so from here is 97.89. So in 3SF, then we can get 1.95 meter per second. So yeah, as you can see, the snowball actually changed direction because obviously they follow the girl and the slash, right? So the snowball did actually slow down the velocity of the girl from 2 meter per second to 1.95. So that's like a logical answer. Okay, so yeah, that's it for the example here. So you'll realize that all this example is basically focused in the part where we try to use the principle of conservation. So your past year question is going to be harder because they combine the part of force as well. But the only thing that I can say is always remember that in your conservation of momentum, right, we only involve the velocity and the mass only. There's no acceleration involved. So which means anything to deal about anything to deal with force is actually the part to tell you the acceleration. So as you have the acceleration, then you go back to the super. So that's like the idea on how these three lessons actually combine to each other. Okay, so yeah, just try to use some time to actually think about the question and try to figure it out. So basically, you have F equals to MA, then the suvat, and also the P equals to MV. So something that you can realize is this part and this part, they are not connecting with each other because of this part, they do not have A. So the part where you can connect the A and V together is actually by using suvat. So that's why when you try to solve this, I hope that you can see the idea of how are you using Suba to actually connect all the variable that you want. Okay, so yeah, spend some time to think about that, and that's basically for today's lesson. So yeah, if let's say you have any question, then feel free to ask me personally. All right, thank you.